All right, if you're into AI at all, you know this feeling, right? You open up your feed and boom, it's just this tidal wave of new papers, new terms, all these crazy new architectures. It feels like you're just treading water, trying not to drown, let alone actually understand what's going on. I mean, look at this. You see this constant stream of buzzwords. LoRa, RLHF, diffusion, retrieval, Mamba, agents. It just keeps coming. And you try, right? You try to learn them one by one. But the second you think you've finally wrapped your head around one concept, 10 more just pop up. It's this never-ending chase, and honestly, it can be totally overwhelming.
Yeah, and this quote right here, it just hits the nail on the head. It feels like you're collecting names, not building understanding. The real problem isn't just the speed, it's that learning a new term in isolation doesn't really help. It doesn't tell you where it fits into the bigger picture, or why it even works, or, and this is the big one, how to take that idea and use it somewhere else. It's like you're just collecting a bunch of puzzle pieces, but you've got no box top. You have no clue what the final picture is supposed to be.
So, that leads us to the big question. The whole point of this explainer, really. Is there a better way to do this? Is there some way to build a mental model that can actually grow with the field, instead of just getting crushed by it every week? Well, I'm here to tell you the answer is yes. And the solution is this really cool idea called the cognitive hologram of AI knowledge.
Okay, so the first big mindset shift we need to make is this. The problem isn't a lack of information. We're swimming in information. The problem is a lack of navigation. Most people get lost not because they don't have enough facts, but because they don't have a map.
And this map metaphor is just perfect. Think about it. Learning a specific technique, like, say, transformers or diffusion models, that's like memorizing individual street names. Sure, it's useful if you happen to be on that exact street, but without a map of the whole city, you can't answer the really important questions, can you? Like, where am I, big picture? How does this street connect to that one? And, maybe most importantly, if I hit a dead end, how do I find a different route? Where do I even begin to fix the problem?
So what if, instead of just collecting more and more street names, we had something like a cognitive operating system for all this AI knowledge? And this OS would do two main things. First, it would give us a stable structure, a map that doesn't completely change every single week when a new paper drops. And second, it would give us a handful of really powerful commands or mental moves to navigate that entire landscape. And that's precisely what this whole framework is designed to be.
All right, so how do we actually build this thing? This cognitive OS? Well, the framework is built on a 3-layer architecture. But before we get into the layers, we need to talk about why it's called a hologram. That part's pretty key. Okay, think about a photograph. A photo is what's called a projection. It takes a real 3D object and just flattens it into a 2D image, right? Well, learning often works the exact same way. If you only look at AI through one single lens, like, say, only focusing on the model architectures or only the applications, you're getting a projection. You're getting a flat, incomplete picture of what's really going on.
But a hologram is different. It rebuilds that missing depth by combining a bunch of those flat projections from different angles. So a cognitive hologram isn't a thing, it's a practice. It's the act of intentionally switching your perspective. You look at the same idea from all these different angles until, bam, the true three-dimensional shape of it just pops into your head. And that's the secret. That's how you build understanding that you can actually take with you and apply somewhere else.
So how is this hologram actually built? It's structured with 3 core layers. Think of it like an onion. Right at the very center, you've got the learning engine. The next layer out is the foundational AI backbone. And then, on the very outside, you have the contextual layers, which is what connects everything to the real world.
And if you remember one thing, make it this. It's super simple. The engine is how you navigate, the backbone is what you navigate, and the context is why it even matters. How, what, and why. That's the whole system in a nutshell.
Okay, let's dive into that core layer, that innermost piece, the transdimensional learning engine. And this gets to the heart of it. This layer isn't about what to think. It's about how to think. It's a set of mental commands that help you think more deeply and flexibly.
So often when we learn, we get stuck, right? We get trapped in a single dimension. We're either lost in the weeds with the tiny details, or we're stuck with just one high-level perspective. Well, this engine gives you 3 specific commands to break out of that trap. You learn to zoom across different levels of detail from the micro to the macro. You learn to shift between different ways of looking at the same thing. And you learn to bridge ideas from AI to completely different fields.
Okay, this might sound a bit abstract, so let's make it super concrete with a concept we all hear about, attention. Let's walk through this table. First up, the zoom command. At the super micro level, attention is just a technical thing, right? It's weighting mechanisms, softmax functions, dot products, it's all math. But when you zoom out a level, you see it's really a principle of selective information routing. And if you zoom out even further, it's a general pattern for how any system allocates limited resources. Okay, cool. Now let's shift our view. If we look at it from a process view, it's just a computation stage that happens inside the model. But if we shift to a state view, it becomes a kind of alignment space that we can actually analyze and measure. And finally, the really cool part, we bridge it. This core idea of selective routing isn't just for AI. It connects directly to signal amplification in neuroscience and even to how artists guide our perception in a painting. See how that works? We just took a single technical term and turned it into this incredibly powerful transferable idea.
All right, so that was the how. Now let's move to the what, that middle layer, the foundational AI backbone. In a field that changes every day, this is the answer to the million-dollar question, what doesn't change? What's the stable part? This is the skeleton. It's the structure that everything else hangs on.
Now, what's really clever about this backbone is that we look at it through two different complementary views. There's the process view, which is basically a timeline. It asks the question, when does something happen? And then there's the state view, which is more like a map. It asks, where does something exist? And this isn't just academic. Think about when a model breaks. The timeline might tell you when it broke, say during training. But the map tells you where the problem actually lives. Is it in the input data, the model's weights? And that difference is absolutely crucial if you actually want to fix it.
So let's look at that process view first, our timeline. It breaks down pretty much any deep learning system you can think of into 6 stable stages. It's a workflow. You always start with your input and how you process it. Then you decide on the model architecture. After that, you set your objectives. What's the goal here? Then comes the messy part, the learning dynamics of the actual training process. Afterwards, you've got to do your evaluation to see how it did. And finally, there's adaptation, which is all about making it work in the real world. Every system, from the simplest to the most complex, follows this basic path. It's a reliable roadmap. And then we have the other side of the coin, the state view, our map. This one thinks in terms of spaces. So where does your initial data live? That's the input space. Where do all the learned weights and parameters of the model live? Well, that's its configuration space. And this one's super interesting. Where does the model actually form its own internal concepts and ideas? That's the representation space. Thinking this way, with this kind of geometric perspective, is what lets you pinpoint exactly where a problem is coming from. Okay, so we've covered the how and the what. Finally, let's talk about the why. We're moving to the outermost layer, contextual integration. This is where we see how the whole framework comes together as a super practical tool. This is how the abstract stuff we just talked about gets connected to reality. So, that stable AI backbone we talked about, it connects to the real world through 3 kinds of context. You've got disciplinary context, think scientific laws, or even principles of art. You've got problem context, which is just framing the specific task you're trying to solve. And then you have environment context, which is all about real-world deployment, users, feedback, all that messy stuff. And here is the key takeaway. Most of the time when an AI system fails in the real world, it's not a failure of the model itself, it's a context failure. It's a mismatch between the clean, abstract system and the messy reality it's living in.
So after all this, you might be thinking, okay, but isn't this just another complicated list of terms to memorize? And that is a fair question. But here's the difference. A normal taxonomy just answers the question, what exists? It's a list. The cognitive hologram answers a much more powerful question. How do you learn what exists in a way that you can actually use and transfer to new problems? It's not a list of facts. It's a meta skill. It's an operating system for your own mind.
And let's make this super practical. Here's a routine you can use the very next time you read a new AI paper. Step 1, zoom out and ask, okay, which part of that stable backbone is this paper trying to change or improve? Step 2, shift your views. How does this innovation look from the process timeline versus the state map? And step 3, bridge it. What's the fundamental idea here, and where else have I seen it? What other field could this apply to? If you do this, you're not just passively reading anymore. You're actively building real, structured understanding.
So as you can see, this framework really goes beyond just learning AI. It's a whole new way of thinking, a method for spotting those hidden connections and structures that link completely different fields. It's a recipe for genuine innovation. So the final question I want to leave you with isn't just about how you can understand AI better.
It's about how you can use this way of thinking in your own life. What hidden structures can you now start to see and transfer to your own work, to your own field?